Mm.
Yeah, so Claire, you've just explained a few things there. So just to unpack, you mentioned inside unheated. Do you want to just explain that and just slow that down a little bit for us?
So, for example, if you have a situation where there's a room, well, why would that apply? Something like a garage or a warehouse that's attached to the building. It's not a very common one, that really, because, well, it's a bit of an anomaly, isn't it? Because we don't use heating. uh, it's just whether or not it maintains the 20 degrees that we would hope the pass has to achieve.
So you maybe talked about a room that doesn't have people in it a lot, that are basic appliances.
Or, well, even maybe something that's used as a refrigerated store or something like that within the building.
Yeah. So just calculating these rooms that are a bit anomalies,
Yeah.
really.
Um, so I'm not sure why I put inside there, so I did mean outside unheated.
All right. Okay.
Yes,
So
I do.
yeah, so that's something to pick up in. Obviously, all these slides will be given, and people will be able to look. And we'd recommend with some of the small detail of the text that we do that. Um, but also one of the things that we always want to remind people of is that uh, we don't need to be scared of maybe an abbreviated term or something like that. That it's just a system that people can tap into. So the PHPP is a system that people can use. You know, the shorthand abbreviations. Um, you can Google and you can find out. So you don't have to be a scientific genius to be able to use this.
It's really it's a bit like the spreadsheet that an accountant would use to assess, your financial situation. It's basically putting all the numbers in and getting the truth out of where we're really at.
Absolutely. And so all this detailed information means that you can't sort of hide from the predicted reality.
And that's why we can be so confident that the building will be performing well.
Excellent stuff. Um, yeah, you mentioned eco in one of the slides,
Yeah.
and I just wanted you to unpack that a little bit as well. What's eco? What was you referring to there?
Um,
Yeah.
oh, look, the eco is a word that's thrown around a lot. It has, I'm sure, many different meanings to different people. And it can be the type of products that you use, whether they're sustainable or not. It can be the fact that it's got lots of renewables in the buildings, therefore it's not cooling on the grid as much. It can be lots of different interpretations. And we find that lots of people say, "Oh, we've done it passive or we've done it eco." There's nothing wrong with that per se, but has it been tested against all these factors that we've discussed? Is it comfortable to live in the end? Is it actually as economical as it says on the tin? Have we spent too much money on renewables when we didn't need to? Have we put in things that we didn't need to put in? And I think, and I guess it's, people say, well, we don't need to go that far. No, you don't need to go that far, but then are you certain of the outcome and the fact that the building will perform? And it's a very useful tool to give you that certainty, both in terms of the performance, but also in evaluating what's a cost-effective solution to ensure that you're not throwing money at things that you don't need.
Yeah, absolutely. And this is why we're such supporters of the PHPP modeling system. Um, and really, what we're really interested in is the ability for people to be able to look at something and understand it. And that's what the PHPP does. And it means that we can't have greenwashing, which is a term that is used a lot these days. As is companies might just throw a term out there, um, and almost prey on the naivety of people because they don't have enough understanding, and that's where we're really passionate about is just educating people so they understand the information that's being given to them.
Totally. So again, we can run, we can say we're not going to run a PHPP and slightly wing it and say we built passive, but we're not sure if it's performing passively. We can do the PHPP, and provided everything happens as it's stated, like the lambda values or the relationship of walls to windows and stuff, provided it all happens as it's being modelled in the PHPP, it will and it will hopefully perform as it says. You can do one step further than that, and you can have it certified, and you can say, well, actually, I want this to be cross-checked. And therefore I want to have the site evidence, the photographs, to make sure that all aspects of the construction have been done to the level that we've asked for, and then you get certification in, and that is the final credibility and accreditation, which says it gives you the sort of confidence to say it's definitely a passive house.
Yeah, the verification process very important, but the PHPP itself it is a really valuable tool, and we have had experience of speaking to people who've not used the PHPP, and it has cost them. Because yes, there's a cost to using PHPP and employing an architect or somebody who's knowledgeable enough to be able to understand it, but there's also a cost to not using the PHPP and then rectifying mistakes that may have come up because you've not fully understood the building science as it relates to what you're doing. So it is it is really measure twice, cut once, tool. So we really champion PHPP. Um, we touched on the idea of future stress testing. Future stress testing conditions, and you mentioned that, and I just thought you might want to touch on that and where maybe the data comes from, and this is all through the PHPP.
So the Passas Trust is the British representative body for the Passas Institute. And they have developed what's called the PHT Pastel's Trust Summer Stress Testing addition to the PHPP. And basically it's an add-on, another sheet within the PHPP that allows it to take certain aspects of the modelling, such as the number of people in the building, or the amount of appliances in the building, or the failure of manual ventilation, or something like that. And it says, right, if I block those formula in this stress test, what will happen to the building? Will it be tolerable? And we work within 5% and 10% margins. So in a passive house, it seems crazy in the UK, doesn't it, to be talking about overheating so much. But in a passive house, we have a benchmark of being very low on summer overheating. We want to try and be under 5%. We want to be under 2% in overheating. And we have a top critical point of 10%. If you're 10%, you're not a happy bunny being in that handful or that building. And maybe the reason it's become more of an issue is that the way that the building regulations have been updated has quite rightly addressed more insulation, better air tightness in our construction. Nowhere near past health, but better than it was. And therefore, we have sealed our buildings up, made them warmer from better thermal insulation. We've sealed them up with better air tightness. and we still rely on relatively traditional, in building rates, relatively traditional ventilation systems that extract fans and opening windows, etc. It's not a holistic, it's not a complete package. So what we're finding is that by just addressing the insulation or just addressing the airtightness of the building, we're not actually making it a more comfortable place to live.
Yeah, really important example of that recently, because it has been very warm. So just thought I'd ask you to just explain the sun path. You touched on it, and obviously you've seen it 1,000 times, Claire, and or understand it deeply. But just maybe touch on that again.
Yes, I'm sure you've all noticed when you've been outside, that the sun maybe clicks behind the trees in the winter, and that although it's still daylight, perhaps it's not keeping you as warm, or keep, it's more shading, longer shadows than there are in summer. And the reason for that is due to the angle in the sky of the path of the sun. So when we talk about the winter path and the summer path, we're considering how at what angle the sun comes into the building through all the glazing, through all the windows, and therefore how we can use that sun as a heat source in the winter. And then in the complete opposite way, how we can prevent too much of the sun coming in the summer. And that's why, to think about it, if you have a big overhang, or if you have a canopy, a brise-soleil on the building, it's going to prevent more of the high summer sun and yet allow the winter sun to come in underneath. It's as simple as that.
Yeah, thanks for explaining that, Claire. So just touching on the fabric first approach, and you made reference to the walls, the roof, and the floor, and I just thought you could just unpack that a little bit. Just maybe from a retrofit point of view, maybe some of the considerations you had with the house that you've retrofitted that we're standing today.
Um, there's so many different types of ways of fitting a wall up these days. There's cavity with masonry and blockwork and traditional wet trades. There's timber frame. There's 6 panels. There's all sorts of systems. There's steel frames. And in essence, the wet trades and the steel frames are not necessarily as great for our planet in terms of their carbon footprint. The timber frame buildings have a great benefit to carbon footprint because of what we call sequestration, which means that the timber absorbs some of our carbon. The other huge benefit is that timber frame wall cassettes built off site, or in a controlled environment, ensure a greater guarantee of achieving a passive house if they're controlled off site rather than unpredictable weather conditions. And sometimes wet trades can be more challenging in those situations. However, not to say that they don't have a place, and absolutely do. But the control and the discipline on site of applying those wet trades to ensure that we don't have a manifestation of heat and cold bridges, where perhaps we've got mortar droppings on ties that aren't thermally broken in the cavity and things like that. We want to try and keep those cavities as small as possible. So when you look at retrofit, we consider the existing building and the fabric of the building, what it's been built out of, what might be in the walls, because we're not always sure whether there's any insulation or just a pile of rubble or a few coke cans, and then also how we can best make that perform. One of the big things, particularly with solid wall old buildings, we've got lots of Yorkshire stone around here and cobbles and things like that, is that the walls can suffer if they're restricted on the evaporation of moisture. So using products that don't allow the water vapor to disperse can actually manifest problems which you might not see hidden behind plasterboard and plaster or tiles or other products that don't allow moisture to flow through them. So it's all very site specific and project specific how we tackle that. That help?
Yeah, no, that helps. Yeah, that helps. And you mentioned a little bit about the dew point there and the moisture that might build up in the fabric, and we have touched on this before, but just this idea that the water vapor will become spores at different temperatures, and I might be paraphrasing slightly here and getting it a little bit wrong in terms of the detail, but the spores can actually affect people's health, and it's really important to understand.
There'll be parts to do with the build-up of damp and layers of mold growth, but we may not be aware of them for 30 years till we take down some plaster and then it's behind, and we wonder why it's always felt a bit musty in that room or something like that. And the quality of air takes us on to that, doesn't it, really? The quality of air that a passive house can give you by giving you fresh air, which you probably covered in the MVHL module, alleviates that to some extent, but it's probably best to iron it out and let it happen, the mold growing. And also protect your building. Protect your building. Don't let it rot from the inside out.
Yeah, absolutely. And we may not have touched on this on the course, and so it's worth bringing it up. This retrofit project that was rolled out in Preston, and how it went terribly wrong, and corners were cut. And due to that, the health of people living in the homes were massively affected, and that meant they had to move out. They had to have remedial work done, and so they basically had to spend the same money again in correcting the errors that had been installed originally. So it is really serious that you understand the dew point. It's really serious that you understand the health impact of faulty work or poor workmanship, how that can affect people's health. So yeah, just moving on, Claire. I noticed the graph of the flats versus the houses, and it we're talking about the form factor. That's the one. Yeah, that's the one there. So
Size
yeah, it is. Yeah, it's quite small, I'm sure, for people watching the screen, but they'll have the handout. So as you're looking at the high-rise buildings, they've got a lower form factor, less optimal. So optimal, as I understand what you were sharing, is
no, it's the opposite way around. So this is the place. These are the best form factor is a baked bean can, a tin can. It's like got the least surface area. All the corners have been cut off, and it's just got a round cylinder, and then it's tall. So obviously we don't tend to do that with our apartment blocks. So this one's got lots and lots of floors. Just as an example. So when you look at the amount of floors, which is the treated floor, well, it is the treated floor area, but for the sake of this discussion, there's a lot of floor area relative to the heat loss through their surfaces. When we used to do these little cardboard boxes and look at the actual area of each surface when we used to build them in our maths lessons, then when you go down something here, which perhaps is only single story, but it's a bit like a hospital. Harrogate Hospital was only 2 or 3 stories, but it's got loads of quads, loads of outside courtyards, and so lots of surface area that has to be thermally efficient, and therefore the form factor becomes more challenged by the greater surface area. You can imagine if that number becomes larger for the same amount of floor, then the form factors becomes more challenging. It doesn't mean say that you can't do it. It's just you might have to up your U values, or you might have to really work the solar thermal gain, or consider your appliances to be more efficient, or all those other aspects that we've talked about.
Yeah, particularly at the moment with the energy crisis for the large hospital buildings and big commercial buildings, they're gonna really have quite a poor form factor, and as a result, they're gonna have massive bills.
Yeah.
Yeah. S Excellent stuff. So, I just wanted you to touch just briefly the difference between, a precision modeling tool like a PHPP versus a EPC. Um, we could spend quite a lot of time talking about it. Just briefly touch on that.
EPC is a government sort of led way of people understanding the energy that might be required when you're looking at purchasing or renting, or living in a house, or perhaps renting some workspace, whatever it is. And I think most buildings now are required to have an EPC, and it's just it's a bar chart, isn't it? And it says, oh, it's A rated, or it's C rated, or it's F rated, and it just basically implies the energy performance of the building. And it usually gives recommendations on what one might do to improve that. You could have a more efficient boiler, or you could have some additional insulation in your loft space, or something like that. And it just says, if you took these measures, then you would improve the thermal energy efficiency of the building. It doesn't really cover, it's basically a running cost, in my understanding, a running cost analysis of what this building's going to cost you to occupy, as opposed to covering all the other aspects that we try and address in terms of comfort and health, and performance of the building.
Yeah, so there is quite a big gap, isn't there, between the PHPP accuracy versus EPC, and this is something we've talked about before, and I'm sure that students are looking to this a bit more. But we really are championing this idea of PHPP being an excellent energy modelling tool.
We also got SACS as well, yeah, which is usually a requirement of building regulations. You're not comparing apples with apples. SACS works on very different criteria, and once again was a great tool before the PHPP came along. But I can honestly put my hand on my heart and say that the PHPP will give you a much more accountable end result.